Okay, Khushbu, please introduce.
A very good evening to all. Welcome to day 4, 9 technical session of 6-day faculty development program on electric vehicles and charging station for sustainable development sponsored by AICTE ATAL. And our resource person for this session is Chirabrata Bhowmik sir. On behalf of the organizing team, I welcome you sir in our today's technical session. Before you start your expert lecture, I would like to share a short biography of you to the participants. Chirabrata Bhowmik sir is principal scientist in TCS Research and under Embedded Devices and Intelligent System Research area. He received MS degree in Software Systems from BEATS Pilani and BE degree in Electrical Engineering from BE College, currently known as IIEST Sipur. He has more than 25-year experience in embedded systems domain. His current area of research is Unibrosive Sensing in Machine Materials Infrastructure Sensing. Prior to TCS, he was with SCL Infosystems Limited, BFL Software Limited, and Rebecca. He holds more than 80 patents in geographies like USA, UE, India, Australia, and has 70 publications in various international conferences and journals. He is a senior member of IEEE USA. With this, I would request our expert Chirobrato Bhowmik sir to kindly enlighten us with his words of wisdom. Sir, please.
Hi, good evening. I will take you to the area of smart manufacturing, the way it is, and these challenges in the future. And since this is a research community for and budding academics, I think we will more talk about the research challenges and as for my company, Tata Consultancy Services, TCS, what we are doing in it. And later on, we can have a question, answer, and queries. Let me present my desktop. 1 minute. Share. Okay. My screen, I think, is viewable to all.
Yes, sir.
Okay. So, what we are talking about is smart manufacturing. So, and we are going to talk about future of smart manufacturing. So, what is smart manufacturing is basically you take like today's smart manufacturing. You can think like you take help of various kinds of sensors. IoT sensors are there, and all your new machines are coming and fitted with sensors. So you take the data from there, take real-time decisions, and you tell what to do. And in future, what is going to happen is actually real automation. Like it will be a totally closed loop systems where using these sensors and getting meaningful output of these sensors, you are going to feed them back to your process system so that it can take decisions accordingly. Currently, most of the places, unless it's very much developed factory, developed countries like India and all, most places you will see like humans are taking decisions. So there are dashboards, there are alerts and all, and based on that, some expert engineers and mechanics, they are taking decisions how to run that system. But in future, this will be really closed loop, and we are going to talk about the challenges there and how it is going to be possible. So I will talk mainly from the manufacturing company's point of view. So currently, what are the challenges like for a manufacturing company to start this smart manufacturing and take decisions like meaningful decisions from the sensor data. The 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 main problem, the real life challenge is actually how, as a manufacturing company, how you balance yourself. Like, see, there will be legacy machines, and in real life, it is like you will see 60 to 70% of these are legacy machines, and many of them are working like from 50, 60 years, and nobody is going to throw that huge capital expenditure out. So these are real life challenges. There will be legacy machines, but they do not have today's sensors there. Then you will have many machines in your factory which will be on your path going to be obsolete, but still they function somehow. So how can you take care of that? And then obviously the best part is the modern equipments which you are going to buy. They are going to come with fitted with all your sensors and taking those sensors data output, and it will be fitted with all. So how do you balance between all these things? So basically, what is like for a big company? So you basically, for these real life challenges, yeah, you need an alternative. It's a totally best solution will always be throw whatever there is out, take your new machines, take all the fitted sensors, whatever is available today, and work. But that's not practical. Nobody is going to throw that out, but you have to have an equipment obsolete strategy, and we will talk of other problems later. So obsolescence in manufacturing means you'll see those legacy machines, like mainly you will see like let's say you take a automobile machine, there are cold press machines. So there will be legacy machines, and they they may be outdated but functional. So you are getting output of this, and you are not going to throw this out. Then there will be machines which are going to become outdated, and you will see that your huge portion that I've talked before, huge portion of your actually factories, like if you take Tata Steel or Tata Power, this kind of companies, if you take, they have from independence time there, or maybe pre-independence time, they have those machines and they are still functional. So, uh, so how do, like, they still function? They are very good at what they do, and then you have to take help for those machines. You cannot just write them off. So this creates that, like, you like main what in computer terms we can say it's a problem of siloed systems. You will have various siloed system at your various, let's say, one of your blast furnaces, your boilers. So everywhere you have data silos. So you, even if you have capability, like, no no system is talking between them. So these are the real life challenges we have to solve. So the silo system and data, like what I was talking, like there will be data silos, like whatever you have your old machines, and if you feed them with sensor, if the new, then you have those data. So they are going to be in that silo. Maybe in your this whatever you produce on, let's say, factory number one goes to your plant number one, goes to your plant number two, but these two don't talk to each other because they have been built in defined times with defined vendors, defined. So they're not talking. So you have silos, very efficient silo system at factory one, and there is another very efficient at factory two, but they don't talk among themselves. So ultimately, your whole process is becoming very outdated. It's not 100% efficient. So so somehow we have to take care of these things. And like in theory, there is something called Conway's law. So the more bigger your company will see, like, and that conversed law say, like your software system application reflect your communication structure of the organization that designed them. So if you are a very hierarchical company, then you will see like you have many workflows, and those workflows by which this data flow will go. Then if you are a linear company, it will flow in different way. So it's a very much practical problem. Like all these silos don't talk yeah, to each other, and then you have siloed equipments like. You will see like when you work in real factories, let's say there is some machine from Rockwell and there is another machine from Siemens. They are not going to talk to each other, though they say they follow all the protocol. But even you will see like in the header there will be something they will put on their proprietary. So your one system will work very efficiently in one plant, and another will not work with. So these are real life issues we need to solve. How do we solve them? And so there is another problem is yeah, whenever there is a manufacturing company, there will be two systems. Like you will have your IT systems, your and IT systems will talk about your ERP data. IT systems will talk about your production output, your efficiency, and then there will be KPIs, key performance indicators. So these are IT systems work. But in your factory, the machines work on the supervisors and all. They work. It's called OT system, the operational system. And OT system is like they just bother about whatever their plant's output. So whatever process they output, whatever conveyor belt and whatnot things are there. So they will make patches and make that work according to their supervisor. So OT systems are generally totally siloed, and OT systems data in real life don't go to IT systems. So these IT and OT totally different, and and they don't convert. Most of the like people are trying, even with after IoT has come, people have thought that it will, but it is still not connected. So so this IT OT divergence creates a lot of issues, and there are such challenges we need to solve there. And so theoretically, what I have told you before, theoretically best solution will be in our language we call it greenfield transformation. So you throw like whenever you have legacy systems, we call it brownfield. So you throw all this brownfield and you take a totally new area with new machines, new factory, new shop floor. But that is not practical because financial investment required will be huge, and like steel factories, automobile factories, they have some assets which are built to last for decades, so you cannot throw them out. And even if you want, like if you have deep pockets and all, but you have to halt the total production maybe for 1.5 year. These are not practical solutions. So, what is the way out? So, next gen manufacturing technology, the main way out is you have to gradually inject new capabilities in existing production line. You cannot throw them out. You have to exist. So, in our language, we call it greenfield infusion. So you basically have to bring the modern technologies into existing manufacturing system. You have sensors, you have the hardware sensors using IoT. You have to somehow you have to feed them, and then in future actually you have to take help of AI for deployment. For at every layer there have to be AI deployment. So so whole thing the today it is very much people driven automation. So it your automation efficiency or machine efficiency, everything depends on the supervisor or on the manager who is overlooking the whole the whole system. But gradually this has to be AI driven automation. So you have to fuse AI in every layer. You have enough data, so and so you have enough data for training. So you have to your AI system gradually should be such that you have to understand the whole system, and then you have many techniques by which you have to optimize the whole thing. And when you do that, and there will be newer algorithms, newer process, whatever newer things, your system should be such that it is adaptable to your future manufacturing needs. So that is what the future holds. You have to be designed today to evolve with the new technology. And obviously, it is not easy. There are challenges. One of the, as soon as you start connecting your equipments into, you make them network, and for making them work fully, you have to interconnect them with various plants and factory. And the very next day, the problems of cybersecurity will start coming. Like our PCs and mobiles, they will also be another equipment which is there for this cyber attacks. So there will be challenges in cyber security, which are need to be solved here, because generally this IoT systems or the OT systems, which are the sensor systems today, which are interconnected with these big machines, they are not that great in security aspects. Somehow, when they are designed, it has not been designed that way. So they are generally very easy for attack, which need to change. So we have to. There are challenges which need to be solved at every layer here when you are introducing sensors for these equipments um, to supervise. There has to be you have to take care of the cyber security aspects of it. So and because since your data is going to now your cloud for more munching and for AI to take decision, so you have to take care so that there should not be, because these are factories internal data. These should not get exposed to outside world for doing other things, for other bad things. So this has to be, and already, like if you see, like last 2 years, there 5 to 10 big attacks have already been done. One of the big was in India itself. Tata Power was hold ransom for 1 to 1.5 day, and the whole Bombay region, they could not provide service for power for 1 to 1.5 days. Toyota in California, Toyota factory in California, there was a huge cyber attack, and there was a huge ransomware. So these attacks are happening. They are too. So they are these somehow we need to solve this. So there will be cybersecurity challenges in next gen manufacturing when everything is getting interconnected. And I have already talked about the siloed data problem. So the data management and integration, there will be many issues whenever the data flows from one system to another. So and there will be obviously the when you are giving the data for AI to take decisions, you have to be very careful about the data quality. There should not be many mistakes in the data. There should not be incoherent in the data. So data quality should be solved. So one of the problems is data quality, which we have to find the challenges and solve them. And next gen manufacturing, since it is gradually, it will become more sensor oriented. Your computer programs are going to take decisions. So basically uh, your definition of skilled worker is going to change. So the future workers need to be more IT savvy. Which is today's day. It is there is lack of skilled workers. The OT, mainly the factory shop floor. The factory shop floor, the guys who work, they know very much about the systems, how it behaves. there, but they are not. They are very challenged when you have to look at the data, time series data, take some decisions. They are not that great. So that skill gap need to be fitted in. And integration, we call it, whenever in IoT language or in cyber physical language, we call it system of systems. So when you have various plants and they are going to share data of their equipment and sensors, it will be a system of systems, which is very complex. And obviously the ethical consideration that is out of scope for us. And the tech stack, if you see, this will be more like the in the future smart manufacturing. You can think like the lowest layer, you can think like there are various, like we are talking manufacturing, so there will be various domains. There will be automotive domains, there are pharma chemical domains, oil and gas. So there will be these domains. And in shop floor, in the OT systems, the machines there, which are going to be controlled by the for PLC. There will be obviously future. Today also robotics come. The robotics and motion controls will be, motor control sensors will be there. There will be various kinds of sensors, and all this data, like if you have legacy systems, they were going to your SCADA and HMI, so you cannot throw them out. But whenever the robotics coming, like many robots, like old days robots were controlled by PLC, but new age robots are coming with ROS and all. So those how it will behave, and this has to be get integrated. And when you see from a IT point of view, from a research point of view, you will see like in a OT and IT system, there will be plethora of protocols. There will be HTTP, there will be Modbus, OPC-UA, your Siemens Profinet, MQTT. So there has to be developed a unified platform which is going to take care at this layer, so that your upper layers, because over there on your unified platform will be your apps, which will be AI driven apps. So today it is like humans are taking decisions, because skilled humans can't understand those time series data and take decisions accordingly. But gradually these applications will be more AI driven, and your AI systems are going to take decisions, so that you will really have a closed loop automation. So that will be our future. So I will now talk about some of the use cases in what we as a researcher involved with our customers, or within TCS itself. So like I have talked about your future AI driven things. So one of the things we are working are like machine condition monitoring. So currently, like I was talking before, there are legacy systems. There are no sensors. So, and if you try to put some sensors in your college labs and all, like you can take a pump and put your accelerometers, take the data and all. But in real life, if you go to a factory and say like I will put some accelerometer in your moving machine, nobody is going to allow you, because those legacy machines, OEMs, like they hold because they have the warranty, so that only they can touch them, they can feed them with whatever one. If a third party touch them and all, so then basically your warranty goes for void. So I don't think any any factory manager will be able to give you access for fitting those sensors. So real life, what is like one of the thing is you can use camera, which is you can observe from a distance, what we call unobtrusive sensing, which is like our main research area, and how we can put AI in the force, so that we can do this unobtrusive sensing. So what we are trying to do research on is like we are trying to pick up the vibration using radars. So we are fitting like radars will be like what you call like your cameras without your RGB. So with radars, I'm able to take up the vibrations of around the machines, and using then acoustic microphone arrays we are able to understand the sound coming from various parts of the machines around the machine. So if using them, we are able to our AI based sensing platforms are able to take decisions and can tell like whether any part of the machine is going bad, or any part of the machine is behaving like it's not acting normal. So these things we have been able to do. So this is one of the AI based sensing. So these types of things are going to come. You as a third party, you will be able to do this. For this, you will not need. And then you can actually then what we are trying, like from insurance point of view, or from a OEM point of view, like today's the factory managers are paying the OEMs, let's say for a visit every 3 months, 6 months, just come and see. And most of the time it is working perfect. So that AMC is something like that. So instead of a scheduled thing, maybe they can take a business decision like only when it is turning bad, then I'm going to call you. So as a predictive maintenance, let's say instead of 3 months, 6 months, it may start going bad after 1.5 or 2 years. So maybe that time only you call the OEM to have a look and change whatever is needed. So these kinds of business models in future are going to come. So we as a technical can only solve them. The business, how business will consume that technique, that we don't know. That is for more business innovations will come in place. Then this is for one of the customers. What we have done is actually like this. These guys are actually what you call providers of this like we do blood test things. So there are complex testing, medical testing equipments are there. So many of them are very costly. So maybe some of the labs. Like our labs at localities, unless it's a very big hospital, they will not be able to buy stuff. So in US and Europe, what they do is these companies themselves have labs at various cities, and they allow small companies to use their facilities, and they charge them on their usage basis, the type of machine and type of machine and the time they have used it. Accordingly they charge them. So currently the way is, it's like it's very rudimentary. It's like our like what we do in our used to do in our labs in the college. Like whenever they enter, they sign it, and then they say use it, and then they say I have used it for 2 hours. They write it, and according to that they are charged. But what these companies are finding out, that there's pilferage. Like instead of like if they have used 5 hours, they're writing 2 hours, and there's a trust issue is coming in place. So they are losing business. So what we have tried to do is actually like using card kind of, let's say remote sensing, like a BLE or UWB tag. We are able to understand who has entered the machine, who has entered the lab, and like when using proximity, we are able to understand who is using the machine, and how the machine is getting used from the vibration sensors and from the acoustic sensors we are able to get. So this is like a real-time thing of who is using the what machine and how they are using. So these data are generated like from the sensors, so the yeah, the AI systems are able to understand that and log accordingly. So future view is once this becomes more robust, the client will be charged in this way. So another way is like how a machine behaves is actually for whenever a machine is switched on, actually like if you have a very good smart meter, or if you have a sensor which can log your current in very small interval of time, you will see that there are spikes and there are trends. So whenever machine is actually going bad, these peaks and this behavior change, and from there you can see whether the machine is going bad or not. So from like this is also a kind of non-intrusive sensing. Like you can use smart meter, or there are low cost sensors, Hall effect sensors available, which you can put on your live wire, by which you will understand how the machine is drawing current, and from there you will be able to tell about your machine load and machine health. So this is one of the way you can use AI sensing. And like in future smart manufacturing, like today's technology is all most commoditized sensor is your camera. So you will see today's smart manufacturing everywhere. Like you will see like your quality of the material decision, your machine health decisions, they are getting taken care by using AI on your camera data. So camera is a very commodity item. So and its data is also very well researched, and there are already a lot of AI algorithms available to crunch on that data and take decisions. But what we are trying to in future, what we will be able to see is what is happening inside. Let's say in a cement factory, or let's say in a mineral processing factory, but these big crushers are there. So these big crushers, there is no transparent window and all. So it's a huge things which revolve, and which like our whatever in our home mixtures do. So it is kind of that, like a cement factory. They mix those cements, and in these iron steel iron ore manufacturing companies, they pelletize the iron ores there. So there are huge balls which actually crush the iron ores into small pellets, and there are liners to protect the wall of these huge rotating bodies. There are liners, and those liners also get wired out. So currently it is like every 6 months to 6 to 8 months, or 3 to 4 months or 6 months, these machines yeah, are stopped for 3 4 days, and then people, the workers enter them with sensors to understand what is the inside condition, and then accordingly they take decision. And they have very expert workers who from the sound of the machine, they understand when they have to charge the machine with new balls and all. So which is very heuristic. So instead of that, in future what will come, like using your vibration and the acoustic, you will be able to tell actually what is happening inside. So that is all AI based sensing about, like going beyond camera. So this is one of the things we are trying to develop with a partner company. And then this is another use case we are trying to do. It is for steel plants and all. It will very helpful. Like basically, this for steel plants, the coke is sent to the furnace for blast furnace for melting the iron and all. But actually, the coal, the way we transport sometimes, many times, mainly in monsoon times, it happens. It gets mixed with other, like say, rocks, boulders, or something. And if these boulders or something are huge rock, if it gets mixed, coal is very soft. But if these boulders which get mixed, sometimes they are very hard. And if it goes into blast furnace, then basically the blade of the blast furnace, before it goes, it can break. And one, if the blade goes bad, that is 6 to 8 hours downtime, which means crores of rupees loss. So that's why, like, well, what we are trying to do is fusing your RGB camera with a polarized camera. A polarized camera is something which will, like, which sends polarized light, and from your reflection it can distinguish between various materials. So basically, whichever is not cold, and if it is big inside, we can understand, we can take decisions in the conveyor belt itself while it is moving. And then currently we are just raising alert, and a worker goes and throws it out. But gradually, in the later AI-based system, a robotic arm will be put in, and which is going to basically examine the problem, to localize where actually the stone or the boulder is, and it is going to throw it off. So this is one of the way AI-based sensing research is going on. Then, like, for like, as I have told you, today it is all vision-based processing of your quality of the materials which is coming out of your various machines. But gradually, like what we are trying to see, like only RGB camera will not do. So because whenever it gets mixed with other materials, polarized camera will do. And sometimes what we are seeing, that there will be like other kinds of, like, whenever you want to see inside, like whatever is coming out of your machine, yeah, whether something is happening, or what is the formation inside. So when you try to make formation inside, you have to have more AI based sensing. Like you will, let's say, you have to do imaging which is beyond RGB. So you have to fuse RGB with your ultrasound, with your acoustic, your various with various use cases will depend on various kinds of sensors. And so that is one of our research area, like, by which we are trying to say, like, whether your material quality is good, by fusing your RGB with the other sensors. Sometimes it may be thermal, sometimes it will polarize light, sometimes it's acoustics, ultrasound. So that is one of our research area to like real-time quality monitoring, yeah, using AI-based fusion and sensing. Similarly, weld quality assessment, today's weld quality assessment are mostly are RGB based or human say, but sometimes it is not good, because by the time, like say in a automobile shop floor, there will be like hundreds of sheets are going to weld in one batch. So by the time your quality monitoring system, your RGB cameras tell that it is bad, it is like your 100 batch will go. So you lose a lot of raw material and a lot of effort. So yeah, we will need systems by which, like, whenever it is time to go, when it is going bad, so so we are you in our automobile manufacturing. What is very much popular nowadays is called friction stir welding. So we are doing research on their friction stir welding machine, like the way the spindle moves, and these machines are giving me the output, the power taken and the torque of that spindle. So basically, by understanding that, you will be, whenever we have taken a property called it is forgot the name. It is some so few tensile strength, some tensile strength of the material which is coming out. So whenever welding goes bad, this tensile strength will actually go bad. So using AI-based sensing, we have been able to predict the this tensile strength of the material coming out. So let's say whenever in 100 bad job, maybe after 5 or 6, when we are able to tell, if you are able to tell bad, uh, uh, and then we can give that feedback to the fixed star welding machine that your thing is going bad, maybe your process needs to be modified, something needs to be changed. So if you have already a knowledge base defined in your system, in your AI system, by which you will be able to change the process and make it fully like automated action taken care. So this is one of the kind of AI based sensing which is going to come in future in smart manufacturing for automobile. Then for many of the systems nowadays for quality monitoring of liquids, for paints, and sometimes it is for transformer oil. So nowadays the system is you have to take it from the online to your lab, then test it with a huge machine or small machine, but it is not online. So you have to take it to the lab. Sometimes it is a destructive testing for some of the cases, like where if it is a coating on an automobile sheet, or let's say on your roof sheet, if that kind of thing, you have to measure what is your coating layer thickness, what is your primer thickness. So these are all destructive testing today. And if you have glossiness, glossy or color, all things are like you have to take it off the line, and then so sometimes you lose a so so if you take it from a automation point of view, these are bottlenecks which are not solved. So when your AI system need to solve that, you have to carry some kind of a sensing by which you have to tell online that my coating thickness is not 2 micron what is used to be. It is either more or bad. So and you have to take corrective decision accordingly. So one of the kind of sensing, AI-based sensing we are used called photoacoustic sensing. What it does is actually if you heat it with a laser, since the laser's heat will actually cause ripples in the liquid, and you can catch that waveform, whatever it is that acceleration is given from an ultrasound uh, from uh, from the other side, and using AI based sensing, these are all time series data. So if you know the normal, if you know the various properties of the liquid, like viscosity or temperature, salinity, so or your specific gravity, if you actually can all your physical properties of the liquid actually can be told from this photoacoustic sensing using AI technologies. And today we have limitations, like if the liquid gets me, like if the liquid some chemical reaction happens, we are not able to tell. But that also we gradually will try to solve using photospectroscopy. So these are the kinds of things which are going to we are doing research on. So like similarly to the paints for transformer oil, we are able to tell, like from your those who run your bikes, like like the, from the liquid of from that oil mobile, when from the oil quality, and you will be able to tell when you need to change it. So similarly, like using this kind of thing, photography, we will be able to tell whether how much residues are there, and whether your transformer oil need to be changed. So similarly to that, like like I've told you, what is inside. So some of the cases like refineries and all, we are trying to see when these refineries, like say aluminum refineries, when this liquid aluminum flows via these pipes, they deposit on the inner layers, and these pipes get choked. So so how using some technology from outside, how we will be able to tell whether scaling is happening, what is the kind of scaling happening, what is the inside condition of these pipes. So these are some of the problems we are working. I think that's all from me. And if you have any questions, I will be ready to answer that. Hello, is there any query from anybody?
Dear participant, if you have queries or question, you can unmute yourself and ask question.
Sir, what are the sensors used in smart manufacturing? Like machines to machines, they are talking. So, which type of sensors will be used?
See, these are like today it is a very what you call fractured wall. So like every ecosystem, Honeywell is using one, and like your Siemens is using another. So in PLC wall, if you talk like protocol wise, like OPCU is one of the protocol like which is more or less accepted by all the PLC manufacturers. So these sensors data after going by PLC, they are talking using OPCUA, and then today it is like most of the factories have wired environments. So they are talking using Ethernet. They are taking it to their IoT servers. But tomorrow, gradually, because this what do you call this wiring is also a troublesome area, so it has to be wireless. So with wireless, then basically like when there are too many metals, and wireless will not work. So many other technique like your private 5G, your 6G, RIS, those techniques are going to come, and those will be gradually used in smart manufacturing. Today it is all like to Ethernet and protocol composite. Have I answered your question, or you want something?
Uh, Thank you, sir. Thank you. Uh, I got my answer.
Dear participant, if you have any questions or question, you can ask. First unmute yourself and ask the question. Sir, I think there is no question, so we can
Okay.
end here.
Okay, then thank you all for listening to me. Hope it will help you in whatever you're trying to do, and give you, like I have just tried to give you some insight. Like you have to go deeper and search for that and see what are the research challenges you want to work on. And if you really want to industry also to help, we'll be there to help you.
Okay, thank you, sir.
Okay, thanks all. Good night.